Hey guys, I'm back with a new video. In the previous video, we'll learn about linear regression and how we can determine the coefficients and parameters of our linear regression model. So in this video, let us see how we can implement the data set that we had discussed in one of the previous videos. So in this video, we'll basically perform linear regression on our data set, which is the old natural GitHub dataset with 272 rows. So this is our dataset that we will be working with. And let me show you this. Now, as you can see here, we are having one input variable and one output variable. Your input variable is duration, your output variable is interval. Okay, and we need to perform linear regression on this because as you can see, we are having a single predictor, which is duration, and we are having a single output variable, which is interval. Okay, so if given a new value of duration, can you predict the interval after which the next eruption will occur? So that is what we have to predict. We have discussed the complete problem statement in the previous video. You can check out that video. The link for that can be found down below. Okay, so enough of talking. Let us start with the code. So let me switch back to the file. First, we will import some of the core modules that we will be working with. Let us start importing them. So import CSV. So this is our Python core module that will help us read the data set row by row. Okay. The next one is NumPy. So import NumPy as np. To install this, you will basically have to use the pip manager. So you can say pip install NumPy. Okay. Import SciPy as sp. To install this, you will have to repeat the same command, but you will use SciPy as the name of the package. And then we have import matplotlib for plotting our linear regression line, or basically a model. So for this, you can say pip install matplotlib. And then from matplotlib, import pyplot as plt. Okay. Now first what we need to do is we have to take the data from the file and map it to a form so that it can be used in our Python environment. Okay, so we have to read the data set row by row. But for that, let us first understand what the actual data set looks like, or how we can read the data set. So let me switch to geyser.csv. Let me select the pen first. And you can see that we basically have to set up a CSV reader, and we will be reading the entire data set row by row. Okay, like row 1, row 2, row 3, row 4, and we have to omit the very first row because this row is a header row, and this will not serve in our analysis. It has no role in our analysis because you are having a duration which is a categorical variable. It's not a value that has a certain magnitude, or it is not quantifiable. We are interested in getting these values like 3.6, 1.8, these values for our input values or your predictors, and for intervals as well, because these will serve as labels for a prediction for unforeseen value of duration when we predict later in our implementation. Okay. So what we need to do is we will read the dataset row by row, and if any row contains this duration string, we will omit this. Okay, so we'll continue further and we will omit the particular row that has a string of duration. Omit the row that has the categorical variable. Okay, so we're not interested in working on this row because it's a header row. We'll move to the second row, and that is where we'll start reading the values of x and y. So your input variable collection will have these values, all these values, 1.8, 3.3, 4.5 and all. And then we will have the output variable collection, which is in the form of an array as well. All these values like 79, 54, 74 will go here. And coming to sequence number, we will omit this particular column because we're not interested in using it for our analysis. This is just a sequence number column, and this will not serve anything in our analysis. Okay, so this will, of course, will not be the part of our model. So enough of talking, let us see how we can implement our function for reading the dataset. Now in geyser.py, what I will do is I will write a docstring. So function to read the entire dataset row by row, and map it to a form that can be used in the Python environment. Let us define a function using the def keyword of Python, and I will say read dataset or read data. This will take a file path, and what we need to do is, the very first thing is we need to open the file for reading. So here we are having a CSV file, which is a comma separated values file. As you can see, in a dataset has data in form of a rows, and you can see that the parameters of your model, or you can say these values are separated using commas. So that is why it is termed as comma separated values. So comma separated values. Okay, or CSV in short. Now let us open the file for our analysis. So I will say file, okay, file, and I will say open. I will pass the file path here, and I want to open the file in R+ mode, which basically will give us the ability to read the file as well as write the file. Okay, and this will return us a stream with which we can work with. So we are having a file object. Now let us leave a comment here, and I will say predictors collection or input variables, or input variable. Here the predictor is the duration of the eruption. Here we have a single predictor. So for collecting our predictors, we will use an empty array, and we are having a single predictor for which we'll get all the values for that particular duration predictor, and we'll store all the values in that particular column in our X array, which is currently set to empty. Now let us leave one more comment. So docstring, and I will say output variable. Here it is the duration after which the next eruption will occur. And let us be some more specific. So I will say description, and here also I will say description. Okay, so again we will collect our output variable or our labels in this y array. So I will declare a y as a variable, and I'm setting that to an empty array where we'll collect all the values for our output variables, which is the interval. Okay, now what we need to do is we need to set up the CSV reader to read the entire dataset row by row. So I will say reader CSV, which is our Python core module. It has a method called reader, and this will take the file object. Okay, now no semicolons. Now what we need to do is we need to loop over each of the rows in the collection or your dataset that we got, and we have to exclude the header row like I discussed just now. Okay, we have to omit the header row because that is some categorical data or a string data that we're not interested in for our analysis. So we have to take the input and output variable and add it to x and y. As simple as that. Now let us see how we can achieve that. So I will say for row in reader, and if the row 1 is not equals to duration. So the row will refer to each row in successive iterations. So the first time it will refer to the very first row. So let me show you in the dataset. So when we are looping over the dataset, okay, for the very first time, the row will refer to this row, okay. And you can see if we refer row 1, because we know our dataset is in the form of CSV, so row 1 will refer to this field, which is duration, and it is duration, okay. So we have to omit this as per this check. Let me show you this, okay. So if this is the check, we will be able to omit it, okay. We are interested in getting only these values, okay. We are not interested in getting these. So if row 1 is not equals to duration, we will have to append the entire input variable column to x one value at a time. So we will take the value for input variable from each row in successive iterations. So I will say x, which is our collection of input variables or predictors, x dot append, and I will say row 1, and I will convert that to float and append that to the collection of input variables. And then we need to append the entire output variable column to y one value at a time. So let us copy this, and I will say y dot append float and row 2. So let us again see the dataset, okay. So row 1 is this and row 2 is this for the second iteration. The first iteration will not give you anything fruitful, okay, because we have to omit this. In the second iteration, you will get these values for your input variable, and for your output variable, this is this 79, okay. So we are appending these values, and row is basically a temporary variable that will refer to each row when you are iterating. So in the very first iteration, it refers to this row. In the second iteration, it refers to this. So if you say row 1, you're getting 3.6, and if you say row 2, you are getting 79. And this will work for entire dataset. When you keep on iterating, the row will keep on shifting, and then you can refer these values and store these predictors and the output variable in your x and y, which is the collection of input and output variables, okay. So let us go back to our geyser.py file. And now what we need to do is we need to close the file. So close the file. So on the file object, we have method called close, and this will simply close the file. And now what we can do is we can simply return x and y. And let us try this method first, okay, before proceeding further with our simple linear regression method. So I will say x comma y equals to, the name of our method is read data, and I will pass geyser.py, and let us print x and y to our console. So let us try running the file. So I will say python geyser.py, okay, press enter. So we got an error. It's not py, it's CSV. So let us try again. Okay, so we are getting the values for our x and y's. So let us define the simple linear regression method now.